All right, everybody. Hope all is well with you. We're going to go ahead and work on 2.4 and 2.5 today, do a little lesson on that. But before we do, I wanted to make sure to show you a couple of things, actually. You may have noticed this picture in the background. I'm at home here. There we go. That picture up there is my wife and I when we were in Chicago a few years ago. It was right around St. Patrick's Day, as you can probably tell, and they basically dyed, I think it's called the Chicago River, Chicago, green. So it was freezing out that day, even though the sun was out. At least it was freezing for California folks. There was actually a St. Patrick's Day celebration that day, and there were all these people from Chicago that were out running around in shorts and t-shirts, and then that's what we're wearing. So anyway, and then the other thing I want to show you just is I try and do my best to give you information about me and I want to learn about you is this is a very important shirt. I'm a huge Dodger fan. Let's stretch this out here so you can see it better. So this is my way of getting back at the Houston Astros from a couple of years ago. You may remember they cheated and stole the World Series from my Dodgers. Anyway, so just a little bit about me. All right, let's just jump into this lesson. Not a super long lesson, some good stuff in here. Let me share my screen. I always forget to do that every single time. Okay, so here we go. Move this down here. And we're going to start by talking about the distance postulate. Okay, and I know you read about this, but distance postulate is the distance between 2 points is a what? It's a unique positive real number, okay? Distance, like it's often Ferris Bueller's, can never be negative, right? It's always a positive number, okay? And super important that distance is denoted by between like points P and Q as PQ without the line segment bar above it. This is talking about a geometric figure. It's a line segment, it's a set of points, okay? PQ without that is saying the distance from P to Q is 8 units or 12 units. Okay. What if, and normally we won't see this, but what if the same point went by two different names? Let's say it went by A and by B. What would be the distance? If you're thinking 0, you're correct. It's 0. Okay. All right. This next part I don't think is in the book. It's the distance formula. And it's basically saying that if we have points M and N that have coordinates, meaning like the number that's associated with them on a number line, X and Y, then the distance Mn is the absolute value of X minus Y. Okay? So let's pretend X was 4 and Y was 10. You could basically do 4 minus 10, which is negative 6, take the absolute value of that 6, or, Y minus X. It wouldn't really make a difference, and that would be what? 10 minus 4 is 6, and absolute value of that is obviously 6. Okay, so that's what I'm saying here. Doesn't matter, right? And you're getting all this down in your notes. Doesn't matter which way you do it. It's absolute value. It's always positive. One reminder, make sure you have consistency in units. I think there's some problems in the homework set that use different units, so be careful about that. Okay, let's get into a postulate. Remember, postulates are things that we don't have to prove, and that's the ruler postulate. And one thing I want to make sure is very clear. When I give you a theorem or a postulate, you need to know it. Do you need to know it word for word? Absolutely not, okay? But if I said, what does the ruler postulate talk about, or what's in the ruler postulate, or what does it say, I would expect that you'd be able to tell me all of this, okay? Or understand all of that, okay? So very important that you understand that. Okay, so there's different parts here that make up the ruler postulate. Let's go through it. So, and think, I want you, as you go through this, think about a ruler. Picture a ruler in your mind. In fact, I'm going to put a ruler in your mind. What happened to it? Oh, there it is. It's just at the top. Okay, let me bring that down here. Okay, so we have our ruler here. All right, so what this is saying is that for every point on a line, there corresponds exactly one real number. So let's go ahead and make a point right there and another point right there. If I take this ruler and, oops, there we go. Oops, I need to, and I line it up here, even though those points weren't exactly horizontal. And I put, you know, I could say that on this number line, assume that here's 0 and goes on forever and it goes on that way, that this point, let's say this was point A, has what? It has 3 associated to it. It's the only point on this line that has 3 as its coordinate. And this point over here, let's say it was B, would be what? 8.6, something like that, right? Okay, so it's not going to change, all right, for any particular line. Okay, also for every real number, there corresponds 1 point on the number line. So same thing. If I've got a number line here, this whatever, you know, let's go to 7, right? So 7 would be right there, right? That is the only point that has 7 on this particular number line, okay? All right, and blank is the absolute value of the difference of the corresponding numbers for the points. That would be what? Yeah, distance, right? Distance is the absolute value of the difference of the corresponding numbers of the points. Saw that right up here, distance formula. Okay. And the number corresponding to a given point is called, I already mentioned this, but it's the coordinate of the point, okay? All right, so that's what the ruler postulate is saying. It's basically saying if you lay down a number line, then every point that's on that number line has one real number that's associated with it, and any point that you pick on the line has, you know, or any number that's on the number line has 1 point associated to it. Okay, we also have the ruler placement postulate, which says for any 2 different points, P and Q, a coordinate system can be chosen so that the coordinate of P is 0 and the coordinate of Q is positive. Okay, let's put this to work and see what we mean about that. So let's go ahead and put a point right here, and let's call that point P. And let's go ahead and put a point over here, and we'll call that point Q. Okay. So what we're saying is that we can take a ruler and we can place a ruler down that has the coordinate of P to be 0. Okay, right? And now I gotta move this a little bit, right? Come on, it doesn't want to do it exactly. Let's see. No, okay, you don't want to snap into place. Let's go ahead and do it this way then. Let's move this up here and move this up there. Okay, well, anyway, pretend that point is on the number line. And you can see that it would have a positive number, right? Okay, but you might be saying, yeah, but how would you do that? That, you know, that's if P is smaller than Q. So obviously I can put it at 0 and have it go that way. What if this was P and this was Q? Then how would you do it? A couple ways. Couldn't you turn the paper over and have the ruler go that way? Or better yet, we could flip the ruler over, right? And there's P at 0 and Q at about 11, okay? So that's all the ruler postulate is saying, okay? And can you have irrational numbers on the number line? And for example, can you have pi on the number line? Of course, it's a real number. Yeah, you can. Okay, so let's practice the distance formula. And so I have a number line here, and you can see that the points are listed here. This one doesn't have a point on it either, is that one. That's okay. I don't know that that's important. This is -2 root 2. That would be u. And root 3 is b, and s is pi, okay? And n is y there. So I want you to go ahead and try and figure out, let's do a couple together. What's the distance TL? Well, what's the coordinate of t? 0. What's the distance of L is 4. So you could go 0 minus 4, take the absolute value of that, or 4 minus 0, and you get 4, okay? What about LF? Here it's -4, here it's 4. What's the distance between those? You could probably see, well, it's 4 to 0 here and 4 more here, so it's going to be 8, right? Isn't that what -4 minus 4 absolute value that would be? Or 4 minus -4, which is 4 plus 4, absolute value that would also be 8. Okay, so try the other ones, and then watch me go through them. So pause the video, finish them off, and let's go through them. Okay, so RL, hopefully you got 6. TS would have been T is 0, S is pi, so that distance is pi minus 0, absolute value that is pi. Or if you did 0 minus pi, that'd be fine. What's that? That's negative pi, but you take the absolute values, it becomes pi. Okay, BT, root 3 and 0, so hopefully you got root 3. Distance always has to be positive. What about TU? 0 minus negative root 2 would be the same as plus root 2, so it would be absolute value root 2, which is root 2. Or if you'd gone the other way, you still would have the same thing. You would have negative root 2 minus 0, take the absolute value of that, you still get root 2. And then LB, notice on this one, what do you think you'd have to do? It's 4 and root 3. So it would be 4 minus root 3, which is equal to what? The most we can simplify that is 4 minus root 3. Don't worry unless I tell you otherwise to simplify irrational numbers. You can just leave them like that. That's an exact answer. Okay. Would it be correct to do pi minus 4? Or I'm sorry, root 3 minus 4? Absolutely not. That would be a negative, right? We know the square root of 3 is somewhere between 1 and 2. And then that number minus 4 would give us a negative. So that would not work. Now, if you took the absolute value of it, then it would be fine. It would be the same thing. Okay, BF, root 3, negative 4. So what would that one be? Hopefully you got root 3 plus 4 or 4 plus root 3. And for FR, F is negative 4, R is negative 2. So you should have gotten 2 for that. All right, that's it for 2.4 and 2.5. Again, super important. Take advantage of my availability. I want to work with you guys. I want to get to know you. Happy to do it. It's actually one of the best parts of being a teacher is being able to answer questions and really help kids get over hurdles. I was a tutor for 6 years, and before I finished graduating college and law school and working and all that. But it's really one of the things that really drove me to being a teacher was getting to work in small groups or individually with students. Love doing it, love helping out. So take advantage of it. I'm here to help you. Remember, I care. Okay, great. That will end that lesson, and I wish you a good day.